NENOMATICA, where mathematics meets YouTube excellence. Welcome to this math tutorial, where we'll learn how to multiply polynomials step by step. Today, we'll work through an example problem and see how to use the distributive property and FOIL method to multiply expressions with multiple terms. Let's begin with our example. We need to multiply these three binomials, 2x plus 3 multiplied by 3x plus 4, multiplied by 3x minus 5. When we have more than two expressions to multiply, we'll work step by step, multiplying two expressions at a time. Let's start by multiplying the first two binomials, 2x plus 3 and 3x plus 4. Now, let's multiply these terms out. We get, first, 2x times 3x gives us 6x squared. Next, 2x times 4 gives us 8x. Then, 3 times 3x gives us 9x. Finally, 3 times 4 gives us 12. Putting it all together, we have 6x squared plus 8x plus 9x plus 12, which will multiply by 3x minus 5 in the next step. For our next step, we need to multiply 6x squared plus 17x plus 12 by 3x minus 5. We'll use the distributive property to multiply each term in the first expression by each term in the second expression. Let's multiply each pair of terms. 6x squared times 3x gives us 18x cubed. 6x squared times negative 5 gives us negative 30x squared. 17x times 3x gives us 51x squared. 17x times negative 5 gives us negative 85x. 12 times 3x gives us 36x. And 12 times negative 5 gives us negative 60. Now, let's put all these terms together. In our final step, we combine like terms to simplify our expression. We have 18x cubed. For the x squared terms, we have negative 30x squared plus 51x squared, which gives us 21x squared. For the x terms, we have negative 85x plus 36x, which gives us negative 49x. And finally, we have negative 60 as our constant term. So our final answer is 18x cubed plus 21x squared minus 49x minus 60. We'll examine the expression 7 times a plus b squared minus 7 times a minus b squared. Let's begin by expanding the squared binomials. Using the rule for squaring a binomial, we know that a plus b squared equals a plus b times a plus b. Similarly, a minus b squared equals a minus b times a minus b. So our expression becomes 7 times the quantity a plus b times a plus b minus 7 times the quantity a minus b times a minus b. Now, let's use the FOIL method to multiply the binomials. The FOIL method stands for first, outer, inner, last. This helps us multiply two binomials by multiplying the first terms, the outer terms, the inner terms, and the last terms, then adding all the products. For a plus b times a plus b, we get first terms, a times a equals a squared. Outer terms, a times b equals ab. Inner terms, b times a equals b, which is the same as ab. Last terms, b times b equals b squared. Similarly, for a minus b times a minus b, we get first terms, a times a equals a squared. Outer terms, a times negative b equals negative ab. Inner terms, negative b times a equals negative ba, which is negative ab. Last terms, negative b times negative b equals positive b squared. Now, let's simplify these expressions. We'll simplify each product and combine like terms. The first part becomes 7 times the quantity a squared plus ab plus b squared. The second part becomes 7 times the quantity a squared plus a times negative b plus negative b times a plus negative b times negative b. Remember that negative b times negative b equals positive b squared, and negative b times a equals negative ab. Let's combine like terms within each parenthesis. We'll add the terms ab plus ab to get 2ab in the first expression, and negative ab plus negative ab to get negative 2ab in the second expression. This gives us 7 times the quantity a squared plus 2ab plus b squared, minus 7 times the quantity a squared minus 2ab plus b squared. Now, let's distribute the coefficient 7 to each term within the parentheses. Using the distributive property, we multiply each term inside the parentheses by 7. This gives us 7 a squared plus 14ab plus 7b squared, minus 7 a squared minus 14ab plus 7b squared. Finally, let's combine like terms in our expression. We'll group and combine all the similar terms. The 7 a squared terms cancel out, 7a squared minus 7a squared equals 0. The 7b squared terms also cancel out. 7b squared minus 7b squared equals 0. We're left with 14ab plus 14ab, which equals 28ab. Therefore, our final answer is 28ab. Let's summarize what we've learned in this algebraic simplification. We started with the expression 7 times a plus b squared minus 7 times a minus b squared. First, we expanded the squared binomials. Then, we used the FOIL method to multiply the binomials. Next, we simplified the terms and combined like terms within each parenthesis. After that, we distributed the coefficient 7. Finally, we combined like terms to get our answer, 28ab. This example shows us how the difference of squares pattern works when modified with a common coefficient. You might notice that our original expression resembles the difference of squares pattern with a common factor of 7. Today we're going to expand and simplify the expression. 2 times quantity a plus b cubed minus 2 times quantity a minus b cubed. Let's start by expanding each cube. We'll use the cube of binomial formula, which states that for any binomial a plus b cubed, it equals a cubed plus 3a squared b plus 3ab squared plus b cubed. Let's apply this formula to our expression. First, we'll expand the a plus b cubed term and then the a minus b cubed term. Now we'll expand the products inside each parenthesis. For the first term, we have 2 times the product of a plus b multiplied by itself 3 times. Let's multiply out a plus b times a plus b to get a squared plus ab plus b squared, which simplifies to a squared plus 2ab plus b squared. Then we multiply this result by a plus b again. Similarly, for the second term, we have 2 times the product of a minus b multiplied by itself 3 times. Let's multiply out a minus b times a minus b to get a squared minus ab minus ba plus b squared, which simplifies to a squared minus 2ab plus b squared. Then we multiply this result by a minus b. Let's continue distributing terms. We'll use the distributive property which states that a times the sum of b plus c equals a times b plus a times c. For the first part, we multiply each term in a squared plus 2a b plus b squared by each term in a plus b. Similarly, for the second part, we multiply each term in a squared minus 2a b plus b squared by each term in a minus b. Now, let's simplify these multiplications. For the first part, a squared times a gives us a cubed. 2ab times a gives us 2a squared b. b squared times a gives us ab squared. A squared times b gives us a squared b. 2ab times b gives us 2ab squared. And b squared times b gives us b cubed. Similarly for the second part, a squared times a gives us a cubed. A squared times negative b gives us negative a squared b. Negative 2ab times a gives us negative 2a squared b. Negative 2ab times negative b gives us positive 2ab squared. B squared times a gives us ab squared. And b squared times negative b gives us negative b cubed. Now we'll distribute the factor of 2 to each term inside the brackets. For the first part, 2 times a cubed is 2a cubed. 2 times 3a squared b is 6a squared b. 2 times 3ab squared is 6ab squared. And 2 times b cubed is 2b cubed. Similarly for the second part, 2 times a cubed is 2a cubed. 2 times negative 3a squared b is negative 6a squared b. 2 times 3ab squared is 6ab squared. And 2 times negative b cubed is negative 2b cubed. Finally, let's combine like terms. We have 2a cubed minus 2a cubed, which equals 0. 6a squared b plus 6a squared b equals 12a squared b. 6ab squared minus 6ab squared equals 0. And 2b cubed plus 2b cubed equals 4b cubed. Therefore, our final result is 12a squared b plus 4b cubed. We've successfully expanded and simplified the expression 2 times quantity a plus b cubed minus 2 times quantity a minus b cubed to get 12a squared b plus 4b cubed. To verify our answer, we could also approach this problem using the difference of cubes formula. The expression can be seen as the difference of 2 cubes with a factor of 2 outside. Let's start with an example. We'll simplify the following expression. Let's begin our simplification. In this first step, we'll reorganize the expression to make it easier to work with. Looking at the term x times x squared plus x, we can rewrite this as x times x squared plus x times x. Now, let's simplify what's inside the brackets. X times x squared is x cubed, and x times x is x squared. So we get x cubed plus x squared. Now we'll use the distributive property to multiply each term in the first bracket by each term in the second bracket. This will result in 6 separate terms. Let's start by multiplying x cubed by each term in the second bracket. X cubed times x to the fourth equals x to the seventh. X cubed times negative x cubed equals negative x to the sixth. X cubed times x squared equals x to the fifth. Now, let's multiply x squared by each term in the second bracket. X squared times by each term in the second bracket. X squared times x to the fourth equals x to the sixth. X squared times negative x cubed equals negative x to the fifth. And finally, x squared times x squared equals x to the fourth. Let's simplify each term in the expansion. X cubed times x to the fourth gives us x to the seventh. X cubed times negative x cubed gives us negative x to the sixth. X cubed times x squared gives us x to the fifth. X squared times x to the fourth gives us x to the sixth. X squared times negative x cubed gives us negative x to the fifth. And x squared times x squared gives us x to the fourth. Combining all these terms, we get x to the seventh minus the quantity x to the seventh minus x to the sixth plus x to the fifth plus x to the sixth minus x to the fifth plus x to the fourth. Now, let's combine like terms within the parentheses. We have x to the seventh, 4x to the sixth. We have x to the seventh, 4x to the sixth. We have negative x to the sixth plus x to the sixth, which gives us 0. 4x to the fifth. We have x to the fifth minus x to the fifth, which also gives us 0. And we still have x to the fourth. So within the parentheses, we're left with x to the seventh plus x to the fourth. Now we can distribute the negative sign to the terms inside the parentheses. This gives us x to the seventh minus x to the seventh minus x to the fourth. Finally, let's combine like terms again. X to the seventh minus x to the seventh equals 0. So we're left with negative x to the fourth as our final answer. And there we have it. We've simplified the complex expression x to the seventh minus x times the quantity x squared plus x times the quantity x to the fourth minus x cubed plus x squared, and found that it equals negative x to the fourth. This process involved several key algebraic techniques: distributing terms and using the distributive property, combining like terms, applying exponent rules. These techniques are essential for simplifying complex polynomial expressions. Let's begin by grouping our expression. We have a product of several terms. Let's first group the first 2 factors together and the last 2 factors together. This helps us organize our multiplication process. Next, we'll start distributing the terms in the first group. We'll multiply x squared minus y squared with each term in the second factor. Remember that when we distribute, we multiply each term in the first bracket with each term in the second bracket. Let's simplify the terms in the first group by performing the multiplications. When we multiply powers with the same base, we add the exponents. For example, x squared times x to the fourth becomes x to the sixth. We can further simplify the expressions in the first group. Let's combine like terms and simplify negative terms. For example, negative y squared times x to the fourth power is negative x to the fourth y squared, and negative y squared times x squared y squared is negative x squared y to the fourth power. Now, let's combine like terms in our first group. We have x to the sixth, x to the fourth y squared plus negative x to the fourth y squared, which gives us 0, and similarly x squared y to the fourth plus negative x squared y to the fourth also gives us 0. And finally, we have negative y to the sixth. Let's simplify our expression further. We can write the first group as x to the sixth minus y to the sixth. Now, let's focus on the second group. We need to distribute the terms in the second factor. We'll multiply x to the fourth minus x squared y squared plus y to the fourth with each term in x squared plus y squared. Let's simplify the terms in the second group. Performing the multiplications and adding the exponents for terms with the same base, we get x to the sixth, x to the fourth y squared, negative x to the fourth y squared, negative x squared y to the fourth x squared, and y to the sixth. Now, we can combine like terms in the second group. We have x to the sixth, x to the fourth y squared plus negative x to the fourth y squared, which gives us 0, and similarly x squared y to the fourth plus negative x squared y to the fourth also gives us 0. And finally, we have y to the sixth. Now, we can recognize a special pattern in our expression. We have x to the sixth minus y to the sixth multiplied by x to the sixth plus y to the sixth. This is a difference of squares pattern, where a squared minus b squared equals a plus b times a minus b. Here, I was x to the sixth, and b is y to the sixth. Let's distribute the terms in this expression. We multiply each term in the first bracket with each term in the second bracket. Performing the final multiplications, x to the sixth times x to the sixth gives us x to the 12th. X to the sixth times negative y to the sixth gives us negative x to the sixth, y to the sixth. Y to the sixth times x to the sixth gives us x to the sixth, y to the sixth. Y to the sixth times negative y to the sixth gives us negative y to the 12th. Now, let's combine like terms in our final expression. Negative x to the sixth, y to the sixth, plus x to the sixth, y to the sixth gives us 0. So we're left with x to the 12th minus y to the 12th. Therefore, our final answer is x to the 12th minus y to the 12th. This is the simplified form of our original expression. Let's quickly review what we did. We first grouped the factors, then we distributed and simplified step by step, recognized a difference of squares pattern, and finally combined like terms to get our answer. Thank you for watching. Don't forget to like, subscribe, and hit the bell icon for more math lessons. NENOMATICA, where mathematics meets YouTube excellence.